And to find the inverse transformation, inverse Z transform of 1 by Z minus 2 by division method. Inverse Z transformation of this. Okay. For the first case, actually here if Z equals to 2, then this will be undefined function. Okay. Now we will consider the absolute value of Z will be greater than 2. That means this absolute value greater than 2 means Z by 2 greater than 1, right? Dividing by 2 on both sides. So Z by 2, Z by 2 greater than 1. This is why we can write this from this taking 2 common, we can write Z by 2. Now actually these can be written as we have to divide z minus 2 we have to divide with z minus 2 the sequence we found by z transformation. How this will be z to the power minus 1 z to the power minus 2 z to the power minus 3. That means putting n equals to minus 1 minus 2 minus 3 in the transformation of z. Now this coefficient 1, this one comes from 2 to the power 0, 2 to the power 1, 2 to the power 2 in this way. Okay. So if we divide this series with z minus 2, multiplying 1 by z into z minus 2, we get only 1. First of all 1 we get multiplying with this, then multiplying with this 1, z into 1, z into 1 by z what 1 equals to, right, z into 1 by z equals to what 1. Now minus 2 multiply this will be what 1 by minus 2 multiply 1 by z equals to minus 2 by z. This is why z minus 2 multiply 1 by z equals to 1 minus 2 by z. Okay, we'll start from 1. Then after multiplying this first one with this z minus 2, we get 1 minus 2 by z. Okay, just multiplying with the 1 by z. Now subtracting 1 1 will be 0. Subtracting, we get this, subtracting will be sign change, just 2 by z. Now taking now this one, this 2 by z, after multiplying with this z minus 2 multiply 2 by z square, what will be 2 by z square multiply z minus 2, what will be 2 by z minus 4 by z square, right, minus 4 by z square, 2 to 4, and z multiply this will be only 2 by z minus 4 by z square. Just multiply z minus 2 multiply second term, then you get this one. Now subtracting this will be this minus this will be 0, then subtracting this, just sign changed. Now after multiplication with the third one 4 by z cube multiply this will give 4 by z square minus 8 by z square, and subtracting this will be cancelled. So this is the remainder 8 by z cube. So this series can be written as 1 by z minus 2 can be written as 1 by z 1 by z 2 by z square 4 by z cube, then 2 cube equals to 8 z4 plus 2 to the power 4 16 by z to the power 5. In this way we can write the whole series. So this equals to z to the power minus 1 z to the 2 into z to the power minus 2 z to the power minus 3 z to the power minus 4 dot dot 2 into k to the power minus 1 z to the power minus k. So this is the z transformation of what 2 to the power k minus 1. This is the series of 2 to the power 2 k minus 1, where k equals to 0 to infinity, minus 1 k equals to 0 to infinity. Okay, and so the inverse of transformation of this will be can be written as just 2 to the power k minus 1 by the definition of inverse z transformation, by the definition of inverse z transformation. Z inverse, this can be written as just this sequence only, this one, but z transformation of this sequence can be written as this. Okay, the transformation of this sequence can be written as this. So the inverse will be what? Inverse will be Inverse z transformation of this will be only the sequence one. This is the result, but this is for the case one. If z absolute value of z will be greater than 2, then if absolute value is at less than 2, then we get the same sequence just less than, for less than 2. That means every values will be less than 2. Now now here, uh, minus 1 minus 2 minus 4, this minus 1 minus half, minus minus half y here, minus z by 4 minus z square by 8 minus z to the power 16, just from this sequence. By the definition of z transformation, we can write, just we have to count, we have to introduce minus 1 because less than 2, then minus 1 minus 2 to the power minus 1 minus minus 2 to the power minus 2 minus 2 to the power minus 2 cube minus 2 to the power minus 2, 2 to the power 4. In this way the sequence will be just same division method, just this multiply first one, we get this one. Okay, then this multiply second one, we get this one, second and first, this and third one multiply, we get this, then we get no remainder here. That means this can be written as this series minus, this series will be this one, minus dot dot, taking minus half common, we get a series 1 plus z by 2 z square by 3, z cube by 2 cube, and 2 to z to the power k into twice k. This is the k plus 1 term. So this series can be written as the z transformation of this. So the inverse of this will be 2 to the power minus k minus 1. So in both case we found the z transform, inverse z transform of the sequence by division method. This is called division method, direct division method. Try to practice at home. I hope everybody will do. Now by binomial expansion and partial fraction, binomial expansion and partially fraction, find the inverse z transform of this if the case the absolute value of z greater than absolute value of a, and in second case absolute value of z will be less than absolute value of a. The given series can be written as 4z by z minus a, can be written as 4z by z, just taking z common. Z common will be what? If you take z common from here, this will be given 1 minus a by z, then z will be value of 4z. So this can be written as this. Now if we take the LCM of this, then we can get back to the first term. This equals to 4 into, this can be written as inverse for my 1 minus a by z to the power minus 1, z cancel. So this is the polynomial of a z, a by z. So a 1 minus x to the power minus 1 formula what? 1 plus x square plus x cube plus dot dot. This is the just a series. Now this can be written as 4 into 4 as z to the power minus 1, z to the 4 square z square 4a cube z cube, this way. That means this can be written as the sequence of 4 into a to the power k to z to the power minus k. Therefore the z transform of this equals to this. Okay, but the inverse of this, what will be? Just this sequence, just this sequence will be the inverse z transform of this one. So inverse z transform can be written as just this sequence one. Now this is for what? Z greater than a, absolute value of z greater than absolute value of a. That means z by a greater than 1, z by a greater than 1, z by a greater than 1. That means z is big, bigger. But if z is less than a, then we have to take common what? A. We have to take common a. But if z is greater than, we have to take common z. But if a is the greater than, then we have to take common what? A. We have to take common a. Then taking common a, but there is a minus a. This is why you have to take common minus a. Then we get 1 minus z by a will be this. So this can be written as like this. This is also a polynomial. Now expressing this is in a series 1 minus x to the power minus 1, what will be 1 plus x square plus x cube plus dot dot. This equals to can be written as just multiplied with z by a, then we get this series in every term minus. Why? Because in first we got minus negative sign. So this is the sequence can be written as minus 4 by a to the power k. So the inverse will be inverse z transformation of this will be the just sequence. This is the actually result. Partial fraction actually numerator and denominator. If the degree of numerator less than degree of denominator, then this will be this. And this fraction can be written as like this: if the degree of numerator greater than numerator degree of denominator. That means the above in the fraction, if the if the numerator is bigger, then we have to write like this, and if the denominator bigger greater, then we can write in this way. This is the actually partial fractions. Let any fraction fz by z can be written as like this: a by z minus a, b by z minus b, c. These all are constant. And if we are squared, if in any variable there with a square term, z square plus pz plus q, then we have to write the last two constant in this way, mz plus n in numerator. Then fz can be written as like this, just multiplying with z in every term. So the inverse z transformation of fz will can be written as a into inverse z transformation of this, b into inverse z transformation of this. Actually this is the expression of inverse z transformation in what, in partial fractions, just multiplying the transformation in every term. Now linear non-repeated factor and linear repeated factor. There are actually two types of repeated factor. One is linear non-repeated and linear repeated. Let the linear non-repeated factor be this one, z divided by z minus a. Z divided by z. So the inverse z transformation of this z divided by z minus a can be written as like this. How? Actually taking z common, right? Taking z common, z will be cancelled because z is the greater one. Z we have to take common here z. Then this will be the sequence of what, a to the power k. Actually this will be polynomial of a to the power inverse 1. This is the sequence of this. So z transformation of this will be the a to the power k, where z is greater than. On the other hand, z inverse z transformation of this will be this one when z is less than a. That means a is greater than 1. So we have to take common here minus a. Okay, we have to take common minus a from this. Actually we have solved like this problem. This one we have solved this problem. Okay, one is z greater than, another is a greater than. Okay, just in two cases we are using here. So this is the linear non-repeated factor. Again, the linear repeated factor, it will be how? Let the linear repeated factor will be this one. That means repeated, z minus b will be repeated. Understand? So one term will be always repeated. This is why this is called linear repeated factor. This where r greater equal to 2 and z must be greater than or greater than b. Okay, this is the absolute value actually. Now inverse z transformation of this can be expressed as inverse z transformation of the this one, z to the power minus r minus 1 just whole power, z to the power r divided by z minus b to the power r. Actually this can be written as k plus 2 minus r, k plus 3 minus r in this way, and then b to the power k minus r plus 1, r minus 1 factorial. Actually ncr formula, combination formula, writing the combination formula, we get this one. And so the inverse jet transformation of this can be expressed as taking minus common. Okay, minus common. Why? B is greater than 1, so you have to take common B. And if z greater than, then that you have to take z common. So in this in the linear repeated factor, we have to write these two cases. Now quadratic non-repeated factor. Quadratic you must know, x square plus bx plus c equal to 0. This is the quadratic equation. So like this factor z square plus bz plus q, this is actually quadratic factor. This is the, let the quadratic non-repeated factor. This is why it is called non-repeated. And just comparing this one with this z transformation of this, we have already solved this c to the power k cos alpha k. We have solved in previous example, in previous lecture. Z transformation of this was this. Here p equals to minus 2c cos alpha and q equals to c square. Just comparing with this one. Okay, comparing with this, p equals to what will be minus 2c cos alpha and q equal to what, c square. Q equal to c square. So z transformation of this can be written as just p equals to this and q equals to this one, where p by minus twice c will be cos alpha. If we convert cos hyperbolic alpha equal to cos alpha, then we get this one. Now taking absolute value of this will be less than 1, p by, because maximum value of cos alpha what, 1, minimum value what, minus 1. This is why this value less than or greater than 1, because cos alpha lies between 1 and minus 1, and this is given by minus this, and alpha will be this hyperbolic one. So let this less than 1. Actually this is the theory. This is the quadratic non-repeated uh, factor theory. So this quadratic one can be written as when p by 2c is less than 1, then we can write this. For greater than 1, then we can write this one in this way. So inverse transformation will be just the main sequence of this plus this one, c to the power k cos hyperbolic alpha k. This is actually theory. Now we will introduce example related with it. Find the inverse transformation of this one. If there are three cases, z transformation of this. Hey, hello. Find the inverse z transformation of this one, z minus 3 and z minus 2. When z is less than 2, absolute value of z is less than 2, and if absolute value of z lies between 2 and 3, and absolute value of z greater than 3. In these three cases, we have to find out the inverse z transformation of this one. Now fz equals to, this can be written as just two fraction. Okay, just z minus 2 minus z minus 3 in numerator can be written as z minus 2 minus bracket z minus 3. Then we get these two fraction. So if absolute value of z less than 2, that means 2 is the greater. So taking 2 common here and taking 3 common, so we have to take common minus 3 and there minus 2, so minus minus will be plus. Then we get 2 polynomial in z by 3 and another polynomial in z by 2. So 1 minus x to the minus 1, what will be 1 plus x square plus x cube dot dot. Similarly 1 minus x to the minus 1, x means what, z by 2. So 1 plus x square plus x cube plus dot dot this one. So multiplying minus 1 by 3 and multiplying half, we get this whole series. So for another case, if z lies between 2 and 3, that means z will be greater than 2 but less than 3, right? Less than 3. So 3 is the bigger here actually. So 3 bigger, this is why we have to take common what, minus 3 as a common. And in this but between 2 and z, who is bigger? Z. So in the second one we have to take common z, because 2 is the less, z is the greater than 2. This is why in the second series we have to take common z, and in the first one we have to take common -3. Understand? Similarly, we form two polynomial, one minus x to the power minus 1, and second one minus x to the power minus 1, same. So putting the polynomial series, 1 plus x square plus x cube dot dot, and 1 plus, and the second one will be this, like this, same. So just multiplying the constant -1 by 3 and -1 by z, we get the whole series is this. So this is the actually fz. Fz means what? Fz means what? Z transformation. Now this, the sequence f of k equals to, this sequence can be written as what? -2 to the power k minus 1, where k greater than 0, and f of k will be -3 to the power k minus 1, where k less equal to 0. If k negative, k will be negative, then this, and if k is positive, then this will be k less equal to 0. 0 means what? K will be negative and k will be positive. Just dividing into two parts. Here k equals to -1, -2, -3. Okay, then this is the less one, and 3 to the power, here 3 to the power 0, here 3 to the power -1, 3 to the power -2, 3 to the power -3. Okay, 3 to the power -4, and this will be the minus negative one. So this will be k less than 0. And for this one, what? 2 to the power 1, 2 to the power 2, 2 to the power 3. But in this way, this will be the 2 to the power k minus 1 series. So for this will be k greater than 0. K values greater than 0 for every constant of power. Now, if z is greater than, absolute value of z is greater than 3, then you have to take z common. Okay, you have to take z common in the first series, and in both series we have to take common z. So after taking common, 1 minus 3 by z, and this will be 1 minus 2 by z. Then the series, same series, we got two series and two polynomial of z of 3 by z, and this is the polynomial of 2 by z. So 1 minus x to the power minus 1 formula, what? 1 plus x square plus x cube, same. Just multiplying, we get this series. This can be written as a sequence of this: k greater equal to 1, this one, and k less equal to 0 will be 0. For k negative, value will be 0, and for k positive one, we get this sequence. Okay, this is the z transformation of this one. So find the inverse z transformation of this one if z is greater than 5. Now z transformation of this equals to taking z common, because z is the greater than 5. Taking z common, that means we get common what in bracket. If we take common z, then 1 minus 5 by z will be cube. So z cube will be the common. Now this can be written as the polynomial 1 by z whole cube, 1 minus x to the power minus 3. Okay, 1 minus x to the power minus 3. But this polynomial can be expressed as binomial theorem. How? 1 plus 1 plus x, 1 plus x, uh, 1 plus 3c1, 3c2, 3c3, in this way. That means 1 plus 3c1 x means what? 5z to the power minus 1, 3c2, 3c3, this one cube, this will be 1, it is square, this will be cube. In this way we get the nth term will be this n plus 1 n plus 2 divided by 2, 5 something x to the power n plus dot dot infinity. Now if we take this is the z to the power minus 3 will be the common, the nth term can be written as k plus 1 k plus 2 divided by 2, 5 to the power k, just coefficient of z to the power minus n. Okay, z to the power 5 to the power k, z to the power minus k. Just replacing n with k. Then this can be written as z to the power minus k minus 3. Now replacing minus k minus 3 with k. So k equals to what? K minus 3. Okay, just putting k equal to k minus 3 in this sequence. Then we get this one. So the inverse z transformation will be inverse z transformation of f of z will be what? F of k. F of k means the sequence. Sequence which one? This second bracket one. K minus 2, k minus 1 divided by 2, 5 to the power k minus 3. And this will be for what? K greater or equal to 3, because 5 to the power 5 to the power k minus 3 will be what? K minus 3 will be positive. This will be positive. So k greater or equal to 3. K minus 3 greater or equal to 0. This is why. And for less than must be 0. K less than 3, this will be not satisfied, this sequence. This is why the sequence value will be 0. Now 32, inverse the transformation of this we have to obtain, but the condition if 1 by 3 less than absolute value of z less than half, that means absolute value of z will lies between 1 by 3 and half. In second condition, half will be less than absolute value of z. If we are given z transformation is this, we can take common what here. This can be written as z minus 1 by 3 minus z minus half. This in numerator we can write this minus this. Okay, then we have to put 6 here to cancel 6, because we get 1 by 6. So 6 will be cut, then 1 will be exist. So just partial fraction, making partial fraction. So 1 divided by z to the minus half divided by 1 divided by z to the minus 3. This can be written as like this. Similar process, fz equals to, for 1 condition 1, fz equals to, this can be written as 6. We have to take half is the greater than. Okay, half greater than, we have to take half common, but half not only half, minus half common. So minus, taking minus half common, we get this. But we, if we multiply with this one, then we can back to this term. But 1 by 3 is the less of z, so taking z common, because z is the greater. So taking z common from the second term, we get of the denominator. So we 1 minus 1 by 3z. So this is also polynomial, can be made polynomial. Now this will be minus 12, because 6 divided by minus half can be written as minus 12. So this will be 6 by minus z, 1 minus x to the power minus 1. This is 1 minus x to the minus 1. This is also polynomial. This is also polynomial. This can be written as like this, and this also like this, 1 plus x square plus x cube plus dot dot. Now multiplying in each term with the minus 12, or and making sequence minus 12 to the power 2z to the power k. Okay, for k equals to 0 we get this, k equals to 1 we get this, k equals to 2 we get this. Similar case we can make it another sequence, 1 by 3 to the power z to the power k, right? For k equals to 0, this one, k equals to 1 will be this, k equals to 2 will be this, k equals to 3 will be this, and this is the kth term. So the whole line can be written as minus 12 to the power 2z to the power k, and minus z, just multiplying this z with this one. So this will be 3 to the power k and 1 by z to the power k plus 1. So the sequence can be written as this, can be, this sequence will be exist fk equals to minus 6 divided by 3 to the power k, just constant one, 3 to the power k minus 1, if k greater than 0. Okay, if k greater than 0, greater than 0, that means if k equals to 1, we get 3 to the power 0, that means first one. K equals to 1 will be only 6, k equals to 2 will be second term, k equals to 3 will be third term. In this way, this means this can be written as for k equals to greater than 0, and minus 12 to the power minus k can be written as for k less than 0, because this is the minus 2 to the power minus k, remember it. So k less than 0 means what? If minus 1, k equals to minus 1, then 2 to the power 1. Okay, 2 to the power 1. K equals to minus 2, then 2 square. And k equals to minus 3, then 2 to the power cube. That means this one. So this is the actually inverse transformation for the first condition. Inverse that transformation for the first condition. Now for the second condition, half is the less than z. That means that is the greater one. So we have to take common z first. For every case, every term, from every term, we have to take common z from the denominator. Understand? Then making the polynomials of 1 by 2z, and this will be the 1 by 3z. So making altogether we get this two series, 1 minus x to the power minus 1 formula, 1 plus x square plus x cube. In this way, this is also another polynomial of 1 minus x to the power minus 1. That means this will be can be read as x 1 minus x to the power minus 1. So 1 plus x square plus x cube. So this whole series, two series can be written as arranging this one. Okay, z to the power minus 4, multiplying with z to the power minus 1 to every, and this also z to the power minus 1 to every term in the second series. Then we get this one. So this 6 into this can be written as 2 to the 1 by 2 to the power k plus 1 z to the power minus k. This is the standard form of this series sequence. This is the sequence one, and this is the z transform. And this is second series can be written as also 1 by 3 to the power k plus 1. For k equals to 0, 1 by 3. Okay, for k equals to 0, 1 by 3. For k equals to 1, third term. In this way, inverse z transformation of this will be, this is the actually inverse z transformation of f of z equals to f of k, only sequence. This is the actually sequence. F of k can be written as 6 into 1 by 2 to the power k plus 1, and 1 by this one, taking 6 common. For k equals to k greater equals to what? 1. This condition applied only for k greater equal to 1, because k equals to 1, for k equals to 1 we get first term, for k equals to 2 second term. In this way, this is why we have to apply k greater equal to 1 condition to take this series. This is the actually inverse transformation of the given function. Okay, similar case, we can obtain this uh, inverse z transformation applying this condition that absolute value of z will be lies between 2 and 3. But actually this function is a we have to make partial fraction. We have to make partial fraction using our previous experience. How this can be expressed as this: a divided by z minus 3 whole square plus b divided by z minus 3 and c divided by z minus 2. You must know this can be written as this. That means this can be expressed as partial fraction. ABC are the constant unknown. We have to find out ABC. Now converting into partial fraction, we get this. That means a equals to 1, b equals to 1, c equals to 1, right? Need to, okay. Converting into partial fractions, we get this. This can be expressed as a partially 1 divided by z minus 3 whole square plus 1 by z minus 3, 1 by z minus 2. That means 3 fraction. One fraction can be converted into 3 fractions, where a b c value, constant value will be a equals to 1, b equals to 1, and c equals to also 1. This you have to try it at home to find the value of a constant abc. Now this can be, this is the actually every fraction can be written as actually we have to we are given 3 is the greater than z. That means we have to take common what? 3. from bracket value z minus 3. If you take common 3, then this will be what, like this, 1 minus z by 3, okay, whole square. But after taking from bracket, we have to introduce a square with 3, so 1 by 9, okay, because 3 is the greater than z. Now from the second one, minus, we have to take 3 also common. But from the third one, 2 is the greater than z, right? So which is bigger? Z is the bigger. We have to take common here, z. Understand? Now making it to the inverse, to the minus 2, this inverse minus 2, this inverse to the power minus 1, this to the power minus 1. That means making all inverse, every term inverse, we get the polynomial, 3 polynomials. This is also polynomial, this is also polynomial of z by 3, this is also polynomial of z by 2. Now this is also series from binomial series, theorem series, though it can be written as 1 plus x, 1 plus twice x, 1 plus 3x square, 1 plus 4x cube, like this series. If you try to remember from intermediate, you must know about this series. 1 minus x to the power minus 2. What was the result? 1 plus 2x plus 3 thrice x square plus 4x cube, like this series. Then this is also 1 minus x to the minus 1. This is very easy series. 1 plus x square plus x cube plus dot dot up to infinity, plus 1 by z. This is also 1 minus x to the minus 1 formula. What will be the 1 plus x square plus x cube plus dot dot up to infinity? This will never be finished, so infinite series. If you count it till to death, till to the afterlife of earth, afterlife of universe, counting never will be finished, remember it. So this is the infinite series, but in mathematics it is possible to find out the sum of infinite series. Unbelievable. Now just multiplying 1 by 9 with this series, every term if we multiply 1 by 9, then we get this, and minus 1 by 3 will be multiplied with the whole series, whole second series. Now 1 by z will multiply with the third series, then we get this one. So now we have to make sequence of the series. Actually 2 to the power k minus 1, z to the power minus k, 2 to the power k minus 1, actually 2, here 2, um, uh, 2 by z square, and 2z by 3 cube. So 2 to the power k minus 1 will be for k greater or equal to 1, and k plus 1 divided by 3 k plus 2. Actually 3 term, for every 3 term we have to write k plus 1 divided by 3 to the power k plus 2 minus 1 divided by 3 k plus 1 bracket z to the power k for k less than 0. That means less than 0 means what? Minus 1, minus 2, minus 3, minus 2 up to minus infinity, okay? Or this can be written as, after taking LCM, we get this one. That means this also will be what? K less equal to 0. That means k equals to 0, up to 0, 0, minus 1, minus 2, minus 3, dot dot up to what? Minus infinity. Then this is the sequence, will be the inverse jet transformation of 2 to the power k minus 1 will be the inverse jet transformation of, that's if k greater or equal to 1, and inverse the transformation of f of z will be this one, minus k minus 2 into this will be, can be written as 3 to the power k minus 2, okay, for k less equal to 0. Just this will be the result. Actually this is the finding z inverse, inverse z transformation of the fraction, this, using this condition. Remember it, if z greater than, z must be take common, and if constant greater than, we have to take constant common from every term. Similar process, by using similar partial fraction, we can find out the z transformation of, inverse z transformation of 3z square plus 4z, like this, actually using similar process. This will, you will try it at home. Example 34 will be the homework for you, okay? Example 35 also, just using quadratic non-repeated theorem. Okay, quadratic non-repeated, same formula, same one. Now evaluate the inverse jet transformation of the following from exercise 1 2 3 4 5. Okay, 1 to 5, try it at home. 1 to 5, try it at home. Okay, 1 to 5, 1 to 5 will be homework for you. Now inversion by residue method. Take the contour C such that all the poles of the function z lies within the contour. Then by residue theorem, by residue method, the sequence f of k can be written as summation residue of all z to the power minus k into f of z at its poles, where the residue for simple poles z equals to zi can be written as z minus zi into z to the power k minus 1 f of z at z equals to zi, at z equals to zi. Now residue of order r at the pole z equals to zi can be written as 1 by r minus 1 factorial dz order will be r minus 1. That means r minus 1 times differentiation with respect to z. Z minus zi whole to the power r z to the power k minus 1. This will be same and fz will be same at z equals to zi. Actually this is the residue of r. This formula will be the residue of r at the pole z equals to zi, and this is the simple pole. For simple pole z at z equals to zi, this is the order r. This is why the order of differentiation will be r minus 1. Remember it. Now you have to apply this residue method in in the finding inverse z transformation. Now to obtain the inverse z transformation of this, actually how will we have to use the method of residue method. The pole are determined by, pole means actually we have to find out the undefined condition z minus 2. If z minus 2 equal to 0 or z minus 3 equal to 0, then something by 0 will be, this will be what, something by 0. Something by 0 means what, undefined. Undefined means infinity. The poles are determined by how, z minus 2 into z minus 3 will be 0. That means denominator will be 0. So when 0, for z equals to 2 and 3. Actually these are the two poles. This is called poles. Now there are two poles. Let us consider the contour is z is greater than 3. Now residue at z equals to 2. Residue at z equals to 2 for when z greater than 3. We have to find out residue at z equals to 3. Sorry, z equals to 2 will be z minus 2, z minus 2, z to the power k minus 1 divided by f of z, like this formula. Understand? Zi means what? Only 2. Z minus 2, z to the power k minus 1, and f of z will be the given function, right? Z by z minus 2. This can be written as z minus 2, z minus 2 what? This will be cancelled. At what? At z equals to 2. So z to the power k divided by z minus 3 at what? Z equals to 2. Now putting z equals to 2, 2 minus 3 will be what? Only minus 1. So this can be written as 2 to the power k, z equals to 2, this is why 2 to the power k divided by minus 1. Similarly, for at residue at z equals to 3, if we put z equals to 3, zi equals to what? 3, z minus 3. This will be given z minus 3 to the power z to the power k minus 1, just main function at z equals to 3. This can z minus 3, z minus 3 will be cancelled. So z minus 2 will be exist, and putting z equals to 3 for z in this sequence. So 3 to the power k and 3 minus 2 what will be 1. Actually this sequence will be the result. Hence the sequence partial sum of the residues will be sum 3 to the power k minus 2 to the power k. Very easy. Similar process for example 37, obtain inverse transformation of this. The poles are determined by similar process, just making denominator 0 we get 2, 3, 4. Actually, there are three poles. We have to consider z greater than 4. Okay, we have to, if we consider z greater than 4, then residue at z equals to 2, what will be? Just using the same formula, z minus 2 to the power to the power z to the power k minus 1, the function, whole function, right? Whole function at z equals to 2. Now z minus 2 will be cancelled. Z minus 2 will be cancelled. So z minus 3 and z minus 4, putting z equals to 2 in the whole function, then we get this one, and this will be the whole sequence. Similar process, residue at z equals to 3, using this. Okay, z equals to 3 will be z minus 3 into z to the power k minus 1, the whole function. Z minus 3 will be cancelled, only z minus 2, z minus 4 at what? Z equals to 3. Now putting z equals to 3 in in each term of numerator and denominator, then we get this sequence, only 3 to the power k, just taking subtraction and addition. Again for z equals to 4, residue at z equals to 4, using similar residue theorem by residue method, z minus 4, z minus 4 will be cancelled, and z minus 4 at z equals to 4, remember it. So putting z equals to 4 in the whole term of the numerator and denominator, we get the sequence will be 4 to the power k minus 1. Hence, the partial sum f of k will be sum of the residues, all residues. There are actually 3 residues. So 3 sequence will be taking sum. This is the actually result. Similar process we will obtain. This is homework for you. 38. Similar process, just finding the poles. Finding poles, how? There are 3 poles, 1, 1 and 2, right? So taking absolute values at greater than 2, similar process, proceeding on similar process, once for z equals to and other for z equals to 1, you will proceed, then you will get the same this result. 39 also, we get how many poles here? 3 poles, 1 by 3, 1 by 3 and 2. So this will be the greater than 2, absolute value z will be what? Z will be greater than 2. So once for z equals to 2, and others for z equals to 1 by 3, using same formula, right? Now actually this is a little bit different, a little bit different. uh, 38 is a little bit different, using the second method, second one, this one, residue of order r at the pole, this, using this one. Okay, for the 38, observe that the poles are determined by this. Now residue at z equals to 2, actually this is the second order, right? The, second order r equals to what? 2. This is why you have to use which one? This one, residue of order r at poles z equals to z I will be this. You have to use this method. Okay, now so the poles are only 1 and 2. If absolute value is z greater than 2, then residue at z equals to 2 can be written as z minus 2 to the power z to the power k minus 1, the whole function, given whole function, right? This is the given whole function. Now z minus 2, z minus 2 will be cancelled, then we get this. After putting z equals to 2 in the whole term of numerator and denominator, we get the sequence 2 to the power k plus 2. Similarly, residue at z equals to 1, but ddz z minus 1 whole square. Why? Actually this is the second order, r equals to 2 here. Ddz will be z minus 1 whole square, z to the power minus k minus 1, the whole function, right? Then ddz will be z minus 1 whole square, z minus 1 whole square will be cancelled, right, at z equals to 1. Now u divided by b method, differentiation of u, numerator will be u and denominator will be what? B. So u by b method, can you remember? Of course, in denominator b square, this will be b square, b into differentiation of u minus u into differentiation of b with respect to z. Remember it. We have to differentiate with respect to z. z to the power k plus 2 x to the power n formula, right? N into x to the power n plus 1, right? Look like this. Just after just taking first differentiation derivative, add z equals to 1. Now putting z equals to 1 here, we get the value. Understand? The sum of the residues will be 2 to the power k plus 1 minus k plus 1. uk, this what? Actually, this from uk. Just introducing the this is used for z transformation. Now similar process 39, you can solve this inverse transformation of this by the same method. The pole sort can be determined by taking this multiplication will be 0, then that equals to 1 by 3 and 2. So there are two poles only, and z will be must greater than 2. So at z equals to 2, we will get z minus 2 into z to the minus k, just taking function at z equals to 2. Now we get this result. Now z equals to 1 by 3 will be what? Actually, this will be the 1 by 3 will be in the second order, r equals to 2. This is why you have to introduce the ddz for this. Okay. And z is the greater than 2. So z minus 1 by 3 whole square. Uh, Introducing this ddz into this. Just putting 1 by 3. Now this will be the result. Here z 3z minus 1 will whole square will be cancelled. Okay. So only exist will be z minus 2. This divided by z minus 2. Now ddz of this can be written as u by b method. Same process. B square uh, b square in numerator, b into ddx of u minus u into ddx of b. Then putting z equals to 1 by 3 in that differentiation, we get the result. Please try at home and practice. I hope this result will be correct. So the sum of the residues will be this one. Now uh, finding the inverse transformation of this z square by z square plus 4, where absolute value of z greater than 2. Then actually taking for pole, for finding pole, you have to consider z square plus 4 equal to 0, right? So z square equals to what will be? Minus 4. Z square equal to minus 4. This equation can be written as z square equal to minus 4, but minus 4 can be written as 4i square, right? Plus minus twice I. This is why there are two poles. One z equals to twice I and other is minus twice I. But we have to consider the absolute value of z must be greater than 2. Now residue at z equals to 2, twice I, using the same residue method, right? Z minus zi, zi means twice I, and the z to the minus k minus 1, z to the power k minus 1, then f of z. F of z means given function. So at z equals to twice I, we get this one. This cancelled, but z square plus 4 will be z square minus z minus twice I, z plus twice I, right? This way z minus twice I, z minus twice I will be cancelled. So only left z plus twice I. So this can be written at, after putting z equals to twice I here, we get this one. Twice I will be 4i. Now this will be the sequence. But I to the power k can be written as, I can be written as cos pi by 2 plus I sin pi by 2 from complex number. We can transform this imaginary number I into what? Cos pi by 2 plus I sin pi by 2. Cos pi by 2 means what? Cos 90 degree, this will be 0, and sin 90 degree equals to 1. This is I. So this I can be expressed as like this: cos pi by 2 plus I sin pi by 2. So 2 to the power k minus 1 and multiplying k with the angle. How? Applying de Moivre's theorem, right? Applying de Moivre's theorem, we can write this power into with the multiplication of angle, right? K pi by 2 and k pi by 2. Applying de Moivre's theorem here. On the other hand, residue at z equals to minus twice I. Similar residue method. Then this breaking z square plus 4, z plus twice I, z plus twice I will be cancelled. So only exist z minus twice I. Now putting z equals to minus twice I, we get this. Applying same minus I equals to cos pi by 2 minus I sin pi by 2, right? Cos pi by 2 means 90 degree, cos 90 degree, cos 90 degree will be 0, sin 90 degree will be 1. This will be only what? Minus I. So minus I can be written as like this. Now to make a sequence, actually we are writing the complex number into trigonometric form. This f of k, sum of the residues will be just taking addition. Taking addition, minus plus will be cancelled. That means sin term will be cancelled. Only twice cos. This will be the twice to this 2 will make only single 2 to the power only k. Okay. I hope everybody can do this. Now find the inverse transformation of the following function by residue method. 1, 1, 2, 3, 4 and 5. These 5 will be very, very important for you. You have to solve it. Okay. Same process. By residue method, you have to solve these 5. Understand?